Now take an example to explain the voltage division rule and current division rule. In the circuit given, we have to find the current I, which is flowing through the cell of 24 volt. Second, we have to find the potential difference across the load resistance RL, which is of 1.5 kilo ohm. And then third, we have to find the rate of power dissipated in resistance R1 and R2. Here, this R1 is in series with the parallel combination of R2 and RL. So this figure can further be made as this is a 24 volt, and then this is in series with R1, which is of 2 kilo ohm, and this is the equivalent resistance of the parallel combination of R2 and RL. And these two resistance are of 6 kilo ohm and 1.5 kilo ohm. So we can write it is R2L. This is the equivalent resistance of resistance R2 and RL. This will be equal to R2 into RL by R2 plus RL. This is the formula for parallel combination. And the values are 6 into 1.5 divided by 6 plus 1.5. So it will be 6 into 1.5 divided by 7.5. On dividing by 1.5 it is 5, and further 6 divided by 5 it is 1.2. So it is 1.2 kilo ohm. Therefore R2L will be 1.2 kilo. Now first we have to find the current I. This current I through the cell will be total voltage, which is 24 volt, divided by total resistance, and this resistance is R1 plus R2L, that is equal to 24 by 2 plus 1.2, it is equal to 24 by 3.2. On simplifying by dividing with 8 it will be 4, and it is 30, and further dividing by 4 it is 7.5. So it will be 7.5, and because we are dividing volt by kilo, so this current will be of milliampere. Second, we have to find the potential difference across the load resistance RL. The potential difference across RL will be same as the potential across the parallel combination of R2 and RL. Therefore, using the voltage division rule, we can write voltage across load resistor RL will be equal to voltage across the parallel combination of resistance R2 and load resistance RL, and this will be equal to total voltage by cell and divided by total resistance in series. This is R1 and R2L, and then the resistance across which we have to find the voltage. So it will be equal to 24 by R1 is 2 kilo ohm plus R2L we have found 1.2 kilo ohm multiplied by 1.2 kilo ohm. So it will be equal to this 24 by 2 plus 1 by 1.2 we have calculated as 7.5 multiplied by 1.2. It will be equal to multiplying, it is 9.00, that is the voltage is 9 volt. Here we have applied the voltage division rule. Third, we have to find the rate of power dissipated in R1 and R2. Power dissipation rate is the I square R if I is flowing through the resistor R. Therefore, power dissipated in R1 divided by power dissipated in R2 will be equal to current in R1 square into R1 divided by current in R2 square into R2. Here we know that R1 is given 2 kilo ohm, R2 is given 6 kilo ohm, and IR1 is same as main current I, and this current is 7.5 milliampere. Now we have to find the current through resistor R2. For this, we have to use the current division rule. Here, the main current I is divided in two branches. One is in R2 and another is in the RL. This is IRL, and the current through R2 is IR2. So current through resistor R2 will be equal to main current divided by two resistances in parallel. This is R2 plus RL, and now we have to multiply the resistors This is RL if we have to find the current in R2. That means we have to use the other resistor. So this value will be equal to main current is 7.5. Resistors are 6 plus 1.5 and then multiplied by lower resistance, this is 1.5. So this value will come 1.5 kilo. Therefore, substituting the value, we will have this IR1 square. This is 7.5 square into resistor R1 is 2 kilo ohm divided by IR2 square. This is 1.5 square and resistor R2 is 6 kilo. So on simplifying, it will be 5 square into 1 by 3, that is equal to 25 by 3. So here we have explained the use of voltage division rule for the resistor connected in series and current division rule for the resistors connected in parallel.